Welcome to data science class. Hi, I'm Vivin Arana and today we will learn about decision tree. So we learned two different algorithms before, linear regression and logistic regression. Decision tree is another one of those algorithms, but in this case we can do both regression and classification. So in Python we have an option to do both of them using decision tree classifier and decision tree regressor. So what is decision tree? So let's look at some of the examples here. So if you look at decision tree, it's more based on a tree structure. For example, this is a data set here for Titanic, and if sex is male or female, if it's not a male, then is survived. If it's male, is the age above 9.5. If above 9.5, then died. If it's less, then depending on how many siblings or spouses they had on ship. So if it's greater than 2.5, died, or if it's no, then survived. So that's how you can probably check how a decision tree looks like. Now this decision tree, as I said, it provides both classification and regression models. So what does that mean? In linear regression, we saw that we actually get a set of values and we can give a value for prediction and it will give me a corresponding value. Whereas in logistic regression, we saw that it's more on discrete values. So you can classify a particular set of data to belonging to a particular category. So true or false, A, B, C. So it kind of classifies those values. Whereas decision tree kind of does both of them for us. So let's look at some example. What I'm going to do is I'm going to pick up data for heart diseases from UCI University, and this has all information about for a particular person whose age is this, sex is this, chest pain type is this, then there's resting blood pressure, serum cholesterol in mg. So if I want to find something, for example, what is the rest blood pressure, how is it affecting cholesterol, or how it is affecting the maximum heart rate achieved. So in that case, what is the relationship between them? Because if you see, it's a bunch of numbers from 94 to 200, whereas here it's 71 to 202 or 126 from 564. When you have a variable number, it's more comes into a regression category. Whereas if you have, for example, FBS, which is 1 true or false, or REST ECG, which comes from 0, 1, 2. So these are kind of classification which can be done using logistic regression, and we will see how we can do that using decision tree. In this case, we can start with target and we can look at different options like slope or thal. What are different values that are available for this? So I'm going to download this data set, which is available in my set. It's called heart.csv. That's what I downloaded. I'm going to go ahead and make a new Python notebook. As usual, I'm going to import pandas as pd. Next, I'm going to get my CSV file heart equal to pd dot read underscore CSV, and put that CSV inside there. Next, let's look at if it came properly or not. Head, and I have these 5 different values. Now to start with it, I'm going to start with y as heart, and inside there I'm going to give target is my dependent variable here. My dependent variable is inside this. I'm going to use let's use resting blood pressure or cholesterol. Let's use cholesterol for this example. Run that. Next, something that we've seen before for using this data to train and test your model. So I'm going to use sklearn dot model selection. More and more of these you do, more and better practice you get. You can import train test split. So once I have that, next is, as you know, we'll get data called as xtrain, xtest, ytrain, ytest from this particular function, where I have to provide x, y, and test size. You probably get used to this by now. I can give the data set as 0.3. run it. Next, I want to get my algorithm, which is from sklearn dot tree import decision tree. So there's two of them, classifier and regressor. I'm going to use classifier. If I have spelled this name wrong, it might give me an error. So classifier, and then I can say DTC equal to classifier, initialize that. Once I have this initialized, I can fit my data set to it, DTC dot fit. Now I have training data for X and training data for Y. Fit that there, and it fits the data set. Now I can get my prediction for Y by saying DTC dot, if you see all of these functions are same, predict for X of test. Run this. Now it will give me the prediction data. Now I have the prediction data and so I can always look at my Y test dot head, and I have my test data. I can check my Y pred from 0 to 5, since it's a array. I have 0 1 1 0 0, so it looks like it's not that accurate as we are used to before, but I can always look from confusion matrix how much is the offset here. So I can say from sklearn dot matrix import confusion matrix. Once I have that, I can say confusion matrix can give Y test and Y pred to give me some data. And if you see 26 right on ones, 26 right on zeros, and these are the incorrect ones which we saw before. If you have not seen those videos, I would say go back and look at them so you can see what I'm actually doing. So next is adding all the values, plus 26 plus 26, and that gives me 57%, pretty low. I can change this cholesterol to, let's try this and see if it does show any difference. So this one is 19 and 35, and this probably total is same number, so it doesn't matter. 59%. So it's got a little better, but we can make it better by using different values, is what you have seen before. I can also change from target this to REST ECG. Now if you look at the data set, REST ECG has 3 different values. So does it work for these 3? Yes, of course, it's a classification method. So I can say this, and let's use the same cholesterol from before. So now instead of giving me a 2 by 2 matrix, it will give me a 3 by 3, because now there's 3, 0, 1 and 2 options. So that's why it gives me this option. Now let's look at the error for this. 21 plus 25, these are all the correct ones. Divide by incorrect ones, which is 19 plus 0 plus 24 plus 0 plus 0 and 2. So I'm going to just say 2. And if you see 1.022, so it's much above. Maybe I did something wrong with the calculation. 21, 25, 0, 19, 0, 24 and 0, 0 and 2. Looks like the math is right, but it has a percentage of 1.02, which means it's perfectly amazing, which is a little bit fishy, but that's how you can actually look at your classification in this particular case, in a case of decision tree classifier. Next, I'm going to show you how to do this for regression. Use the same thing for regression. So I don't want to scroll up, so I'm going to just say heart.head, and I see all the data here. Next, I'm going to take my variables as for Y. I'm going to take this thing, trust BPS, and trust blood BP for the particular user. X equal to heart of, let's say in this case I'm going to use, let's use Thalash, which in this case is if maximum heart rate achieved. So that's what we are comparing here. So rest BP versus maximum heart rate achieved. How is it related to each other? I'm going to copy paste some of the things because they are same. Take this and use that. Next thing, I want the same as this, but I don't want classifier. In this case, I want the regressor class. So I'm going to say regressor, and instead of using DTC, I'm going to say, to initialize this guy, I'm going to say DTR. And once I have that, I need to fit, so I'm going to say DTR dot fit my X train and Y train. Once I fit these data sets, next I'm going to see the prediction values, which is DTR dot pred ict X test. So based on this, predict my Y values. Now test dot head, let's look at the difference. So these are the actual values versus the predicted values. Is this 127, 140, 145, 142, very close, 138, 132, 133, 130, 122, 155. This was a little off, but that's how I can get these values. Now, if you remember from our linear regression, if you want to see the RMSE, the root mean square error, we have to get the function called as mean squared error from sk learn dot matrix import mean squared error. Let's go. Guess I spelled it wrong. If you spell it wrong, it corrects you, so you don't have to worry about that. Next, mean squared error, I'm going to take that. I'm going to say y test versus y pred. Let's see what is the percentage it gives, or the difference that it gives me. 640, pretty high, but that's how it is for these values, and that's how it's defined. So you can keep on changing different values or give more attributes to it. Instead of just this, I can also say I can give cholesterol too and see if it makes it better. So 1768, offset increased quite a lot. So you can kind of try around with all these different values and see what is the best option that you get where the mean squared error is minimum. That's the best thing that you need to do. So that's how, using decision tree, you can do both classification and regression. And again, if you want to change this data set, go for a different one, go to Kaggle, create an account, and then you can probably here get a lot of different data sets available for you to play around with it. If you want to do classification, you can just say classification data set for machine learning. And once you do that, you'll probably find a bunch of different data sets available that are there. You can say, I want to do something for decision tree. So if people have tagged their data set for decision tree, you can get those data sets from here. You can say you want notebooks, you want just data sets. You can kind of get what you want from here and play around with different data sets. So I would say go ahead and try a lot of different data sets for all linear regression, logistic regression, and decision tree practices quite a lot, which will help you get better jobs or kind of improve your knowledge on these algorithms. So if you have any questions, let me know in the chat below.